perpendicular lines. So, firstly we're going to run through some theory and then we're going to do a lot of exam questions. Parallel and perpendicular are kind of opposite. If we look at parallel first, in daily life we kind of know what a parallel line is and we've seen lots of examples before, things like train tracks, so those two lines are parallel and then these are all parallel. Maybe the double yellow lines that you can't park on. In this case, double purple lines you can't park on. Parallel lines. So, mathematically, what does parallel mean? I'm going to draw out our axes, our XY axes, and then draw some parallel lines on here and discuss what they have in common. Okay, so these are examples of parallel lines, and as we can see, they're just kind of the same line shifted up and down, roughly, but should be exactly the same. So what we can deduce from this is that parallel lines have the same steepness, so they have the same gradient. So if we just recap now the equation of a straight line, so the equation of a straight line is y mx plus c, or y mx plus c if you watch that video and you want to think of it like the YMCA. So what can we say about this? We know that m is the gradient and we know that c is the y-intercept. So we've just established from our diagram that parallel lines have the same gradient and this is gradient. So they have the same m value in the equation of a line. So these lines, if I was going to write their equations but I didn't actually really know much about them, I could write this one as y equals mx plus c1, so some crosses the y-axis at some c1 intercept value. Then this one will be y equals same m again, same steepness, because gradient is steepness, plus we might call that c2, or it looks a bit like 0, but, and then this one could be y mx again, so same gradient again, plus c3, so a different y-intercept value here. So as we can see, when looking at the equation of a line and looking at parallel lines, the gradient is exactly the same and the m value is exactly the same. So let's move on to perpendicular lines. Okay, so perpendicular is kind of the opposite of parallel, and perpendicular lines look like this. And that they cross, where they intercept, so where they cross is 90 degrees. So you always have to look out for this symbol here. And if it has that where they cross, then you know they're crossing at 90 degrees and that the two lines are perpendicular. So let's draw an axis and put that onto there. Okay, so in maths on a graph it would look a bit like that. And this here would tell us perpendicular. And it's not as easy as the parallel because as you can see the gradients aren't the same. It's not the same steepness. But what is very interesting is, I'm just going to give you the answer and tell you what it is. So let's say this has L1 has gradient, we're going to call it M1. Then we know from our knowledge and what we're learning now that L2 has gradient, and then this is very important, so we're going to call that M2, which is minus 1 over M1. So basically, whatever the gradient of this line is, you do the reciprocal, so you do 1 over, so you flip it, and you change the sign, so you make it negative if it was positive, or the other way round. Perpendicular lines, what you need to know is gradient M2 is minus 1 over M1. So let's look at some exam questions. Okay, so exam question number 1. Write down the equation of the line parallel to y equals a half x plus 5 that passes through the point 0, 0. So we're writing down the equation of a line, and we know equation of a line is y mx plus c. So we know we need to find the m value and the c value. So we know we need to find the gradient and the y-intercept. Okay, so we've been given in the question that it's parallel to this line. And we can identify from this line that half is the gradient because it's the coefficient of the x and it's in the nice form, so it's y equals. If you have 2y equals, you have to rearrange, but it's fine, so we've got y equals, and this is the y-intercept. So it's telling us that these two lines are parallel, and what do we know about parallel? Same gradient. So therefore, they've basically given us the gradient in our question. So the gradient of this line was the value of half, the coefficient, the number before the x value. So the gradient in the line which asked to write down is still going to be a half, same gradient. Okay, so we've been given some more information that passes through point 0, 2. Point 0, 2, let's plot that. We know this c value has to be the y-intercept, so what's 0, 2? So we know it goes x, y, because the alphabet goes x, y, z. And we know, so we're going along the corridor 0 first and up the stairs 2. So it's passing through this point. And we can see that that point is on the y-axis. It is the y-intercept. So we know, we can see from this, we can read off that it is intercepting the y-axis at the value 2. So our plus c is plus 2. And there we have our equation of a line using the gradient from the line it gave us in the question and using the point which was the y-intercept. Okay, our next exam question is write down an equation of the line perpendicular to y equals 3x plus 3. So what does this mean? What is this telling us? If we know that two lines are perpendicular, we know that their gradients, we do two things. We could do one, reciprocal, brackets, flip, do a switcheroo, and two, change the sign. Okay, so for example, that would look like in an equation like that, but you could think of it as reciprocal, flip, and change the sign. So we need an equation of a line perpendicular to y equals 3x. So we know from the equation of a line y mx plus c, the x coefficient is the gradient, the number before the x. So we can identify that in this equation to be the 3. So we could say that m1, gradient 1, equals 3. That means gradient 2, which I'm going to call m2, is I do the reciprocal, so I flip it, which means I do 1 over, first step, and then part 2, I change the sign, so I do minus, or as you can see from this, m2 is minus 1 over m1. So, now I've got the gradient I need for my equation, I can write down my answer. So I know I'm going to need y, and I need this form mx plus c. I know my gradient for the perpendicular line is minus a third, and then you need the x. And now I need a plus c. And it hasn't actually given me any more information in the question, but basically plus c, this can be anything. So a bit like when we were looking at the parallel lines and you could see that you could shift it down, you could just change that c value. You can do the same for perpendicular lines, they can just move up and down. So let's just pick any value, y equals minus a third x, could be 0, you could just leave it as that, plus 1, for example. So let's do another one. Okay, so let's have a look at this. Write down the equation of the line parallel to this here and passes through this point here. So firstly, we're going to write down an equation of a line, so we know that we're going to have to write something y mx plus c. So we need to know m and we need to know c. So let's work out m first. So we've been given this essential information that the line is parallel to that, and parallel means same steepness, same gradient. So if we know it's the same gradient to this, we just need to work out the gradient of that, which is normally the x coefficient, but we can see, this is very important to note, this has to be in the y equals mx plus c form, so we have to rearrange. So I've got this equation here, and I have to rearrange to get y equals to then determine what my gradient actually is. So I'm going to take the 2x over, positive x on this side, so I'm going to take away 2x on this side, and then I've got a multiplied by 5 on this side, so when I take it over I divide by 5 on this side. So I have 10 divided by 5 and minus 2x divided by 5, so don't forget to do both terms. So what is 10 divided by 5 is 2, then you have minus 2 over 5x. I'm going to write that so the x value is first, just so it looks more similar to this. So we can identify that the gradient, the m term, the x coefficient of the line it gave us is minus 2 over 5. So therefore we know that m is going to equal the same because parallel lines have the same gradient, so minus 2 over 5. So now let's work on the c value, and it has given us more information, so we can't just pick any c value, and pass this through this point here. Let's just sketch this point on a graph. So our x coordinate is 0, so 0 along, and then we're going to go down the stairs minus 3. So we know it passes through that point at at this gradient, so it actually passes through. But the more important thing to note about that, the reason we're doing a sketch, is to see that that is the point in which it cuts the y-axis. That is the y-intercept value, which is the c. So we know that c is minus 3, so that's why it's given us that there. So we know m now, and we know c, so we can just write it into an equation. So m minus 2 over 5, don't forget the x, and then plus c is minus 3. Okay, so this next question is a bit different. So we've been given a list of lines, equation of lines A, B, C, D, E, and it's asking us which two lines are perpendicular. So there's only one thing we need to know about perpendicular lines, and that is what perpendicular is going to mean, and that's going to be the gradient, or the gradients are going to be 1 flipped, so reciprocal, and then 2 change of sign. So we know as soon as we hear perpendicular lines, it's something to do with working out gradients. So firstly, let's find the gradients of each of these lines. So what is the gradient for line A? So we need to rearrange them, this is very important, into y equals something. So if we rearrange equation A, we get y equals, and then we can do 4, and then we take over the 3x, so it becomes minus 3x. Equation B, if we arrange that to get y equals, we need to divide by 2, because it's multiplied onto this side, so we need to divide by 2 on this side, so we divide each term by 2, not just one of them, so don't forget to do both of them. What about C? We want y equals, so we're going to take the 2x over, so we got 3, becomes a minus 2x. Line D is in the correct form. And E, again, we've got the same thing as B. We want just y, it's multiplied by 2 on this side, so we divide by 2, and don't forget to do both terms on this side. So now, let's identify the gradients for each of them. So gradients are, in the equation of the line, the m value, which is the number before the x, so the x coefficient. So it's not just which one comes first, it's the x coefficient, the number before the x. So if I circle those in all my equations, so line A, the number before the x is minus 3. So if you said 4, that's wrong because it's not the coefficient of the x. So here, for B, it's a half. For C, the number before the x is minus 2. For D, the number is 4. And here is an invisible 1, not 0. So let's write them all out. So we have, for equation A, we have minus 3. Equation B, we have a half, minus 2, 4, and 1. So the only two, as you can kind of see, well, I kind of see immediately, which one looks flipped in a change of sign. If I flip B, I get 2, change sign, I get minus 2, which is what C is. And you can tell it's none of these because they don't have any of the same numbers. So if you won, you'd be looking for minus a third, and like we don't have any 3s. 4, you'd be looking for minus a quarter. Minus 3, you'd be looking for positive a third. So the two perpendicular lines are B and C. Okay, so this question, a bit different. Line A passes through points 1, 5, 5, 7. Line B passes through points -1, 7, 2, 1. Show that A and B are perpendicular. So what are we trying to show? Perpendicular, trying to show that the gradient of one is -1 over the gradient of the other. You change and flip the sign, you get the other one. So we can rearrange this equation by bringing m1 up. So it's divide on this side, so it's multiply to get -1. So we can see from this that the gradients have to multiply together to give -1. If that happens, you've shown they're perpendicular. So first of all, we need the gradients. So let's start with line A. So I'm going to call it MA for gradient A. So we know that's a change in y over change in x. So if this is x1, y1, x2, y2, I'm going to do y2 minus y1 over x2 minus x1 for the change in. So y2 is 7, minus 1 is 5, x2 is 5, minus x1 is 1. So 7 minus 5 is 2, and 5 minus 1 is 4, and that is also known as simplified 2/2. Okay, let's do it for B, line B. So what's gradient of line B is equal to change in y over change in x. I'm going to do the same thing here, x1, y1, x2, y2. So change in y is y2 minus y1, which is 7, over x2, which is 2, minus x1, which is -1. So let's work this out. 1 minus 7 is -6, and 2 minus -1 is 2, plus 1, which is 3, which gives us minus stays, and then 6 divided by 3 is 2. Okay, so I now have MA and MB. I have the two gradients. So now I need to do a check that if I multiply them together, I get -1. So 1/2 multiplied by -2 is -2 over 2, which cancels to give -1, therefore perpendicular. And you can say why for using that reasoning. So that's how you do that. If you want to show two lines perpendicular, the gradients multiply to give -1.